guys, sorry to interrupt your video. Just a quick plea, subscribe to my channel please. If you haven't done it already, subscribe. Tell your friends, subscribe. Thanks. Aerodynamics. As a vehicle moves along, it has to push through the air, and this causes resistance. Okay? You know that it takes more energy to walk into a strong wind than it does on a still day, and well, the same applies to a car, obviously. All right. The harder the engine works to push through that air, the more fuel you burn. All right. Just like you burn more calories when you have to walk up a hill. All right, and you get hungry earlier. So a car travelling at 20 miles per hour is hitting a 20-mile-an-hour wind, and at 70 it's hitting 70. Of course, if you had an extra headwind, so maybe you're driving at 70 but there's a 20-mile-an-hour headwind, you're probably hitting 90-mile-an-hour winds. So, you know, it varies. If you have 2 times the wind resistance, you need 4 times the power to get through it. It's exponential. That's why it gets harder and harder and harder to break the speed barriers. It stands to reason that the more aerodynamic your car is, the easier it cuts through the air, and therefore it uses less fuel in the process. Okay? A car is designed to allow air to flow over it. If you put something on the car, it blocks the flow, and you will use more fuel to get more power to push through the air. Right? So you're going to need more fuel to give you the power to get through the air. Right. Roof boxes, for instance, on cars are very aerodynamic nowadays, and the air isn't resisted very much at all. So they actually have very little effect. It's nicely aerodynamic. Having said that, the bigger the surface area at the front, the more resistance there will be, but it is negligible. But as we can see from these ones here, we've got narrow would be best for aero. So this one over here, because the wind would be coming at you from here, this is the smallest surface area. That would be the worst one. Well, these two actually. Same width hitting the wind. But because it's all quite aerodynamic, it doesn't really make that big a difference nowadays. Auto Express, because you know I like to research these things for you, did a test and found that the aerodynamic roof box with a 75 kilogram inside only affected fuel economy by 0.2 mpg, which is not bad really. Okay. My learner car, I'm pointing at the screen there you go, that's better. My learner car has this rooftop box and an L plate. It is aerodynamic, and I hardly notice it's there. I can drive along the car, it just makes no difference to me if it's there or not really, the way the car performs. However, when I first started to teach, I was forced into using this style of roof box. Okay, I had a 1.4 diesel Fiesta, and that was stuck on the top of it, and my car would not get above 70 miles an hour. Now I know you're saying, well, you shouldn't be going above 70 miles an hour, but the point is, if there's another wind blowing at my car, the wind resistance could be faster than 70, even though my car can't get there. So it was a pain in the arse. And if I had a really windy day, it wouldn't even get to 70, right? So because I'm pushing the accelerator right down to try and push through the wind, I'm burning a lot of fuel just to drive at speed with that box on the roof. And I use far more fuel in that 1.4 diesel than I do in my 2 litre diesel now, because I've got an aerodynamic box on it now. Right? Around town with low wind resistance, you probably won't feel it too much, but get up to speed and that Fiesta drank fuel. Jeez, I could not wait to get off that. Some points I even got to the point where I turned it sideways on, so I had the smallest surface area driving into the wind. It made a big difference, right? So don't have anything blocky on top. Get a non-aerodynamic roof box, however, and according to allstarcard.co.uk, one report found an increase in fuel consumption of 50%, but typically it's about 10 to 25. All right. Even an empty roof rack, like I've got shown on this van here, can add 15% to your fuel bill. Roof bars, bike racks, flags, you know, if you're supporting England on the World Cup and you've got the flags on the top, anything outside the vehicle will increase fuel consumption. I should say fuel, shouldn't it? It says full. It should say fuel. Never mind. So, driving style, right. When do we burn the most fuel? Right, so the ones at the bottom, 6 one after than the other, but heavy acceleration. That's the number one place where you're going to burn fuel. So if I'm burning fuel, I'm accelerating and I'm going uphill, so I've got weight to deal with, I've got gravity to contend with. That's got to be horrendous. Acceleration on a flat is better than uphill, and downhill even better. Okay, so that's heavy acceleration. If I do gentle acceleration doesn't burn as much fuel as heavy acceleration. It's simple. And the same applies. If I was doing gently uphill, that would burn more fuel than if I was on the flat, or even more fuel if I was going downhill. Right. Maintaining speed, uphill, flat and downhill. So as you can see, heavy acceleration, then gentle acceleration, then maintaining speed. Now, engine idling is when you've just got the engine sitting there, you've parked up, the engine's running, you go blah, 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 sat at a traffic light, for instance. Okay, that's engine idling. That burns fuel. And a braking, slowing down, but I'll come to that. All right. So high revs burns more fuel than low revs. All right. So here we go. Come back to all of this. Right. So the basics of a combustion engine, which is what a car is. Right. If you're using petrol or diesel, you're combusting fuel, so therefore it's a combustion engine. So the basic rules are: the faster the engine spins, the more power you get, but the more fuel you burn in the process. The lighter you push the accelerator, the less fuel you use. If you let an engine idle, you will burn a small amount of fuel. Varies from situations, depends on how big your engine is, but typically 0.1, 0.2 litres per hour-ish. It's not much, but you are burning some. All right. If you are above idle, so your revs are higher than 800 RPM, and you're not pushing the accelerator, then you aren't putting any fuel into the engine at all. Nothing. It's free motoring. It's a bargain, isn't it? Bargain. Right? So if you, every time you take your foot off the accelerator and you haven't got down to the point where the engine's idling, you're not actually burning any fuel at all. Absolutely free. So ideally, you want to drive most of the time in that situation. Therefore, the less we press the accelerator and the lower the revs, the more environmentally and wallet friendly your driving will be. If your driving style is to drive up to things and stop, you spend a lot of time accelerating, which burns the most fuel. What you want to do is let the car slow under its own momentum. Get your timing right to turn up at the lights or the junction when you don't need to stop. That way, you accelerate less because you're starting from a higher speed. Come to that. Look further ahead and anticipate plan. Again, theory test question. Looking further ahead, anticipation planning. That will lead to economical driving. Look at the route you are driving along and change when you go down that route. Right? Don't just look at the car in front of you and when he stops, you stop, and when he starts, because basically he's driving your car. Right? Example, you are approaching a roundabout and there's a gap in the traffic that you can drive into in 10 seconds time. Well, turn up in 10 seconds time and slide into that hole. Right? Don't just turn up after 4 and sit there for 6, because you've burnt fuel to get there, then you've stopped, now you're burning fuel because the cars are idle, and then you need to accelerate from 0 onwards. Whereas if you just rocked up and you arrived in 10 seconds time doing 20 miles an hour, you just sail out into traffic. You've cruised that whole thing, you haven't burnt any fuel, it's miles more economical. So keep your revs low. In a diesel, gear change before 2000 RPM, and in a petrol, change gear before 2500 RPM. This will keep you in the optimum sort of power to fuel usage ratio for acceleration. And doing this can help you achieve a 15% of fuel saving. So rather than taking it around to 3000 RPM before you do a gear change, just go what? Up to 2 gear, up to 2 gear in a diesel. Right, I've got a couple of graphs, don't worry, I'll talk to them about you. It's fine, don't worry. Right, so what we've got here is accelerating hard and stopping at lights repeatedly. So we're going from 0 miles per hour up to 30, going through the gears if you want, then we cruise at 30, then we come down to stop at the traffic lights, then we accelerate again, and we do this. We're just stopping and starting everywhere because we're just driving to it and stopping. Right. What this does is, whilst you're accelerating, your fuel economy, your MPG, is very low. When you get to cruising, then it shoots up. You go up to 50 mpg. All right. But then when you stop again, of course, miles per gallon. Well, if you're stationary, that's 0 miles, because you're not going to get anywhere, are you? So you get 0 mpg when you're stationary. So your average then drops. Then you accelerate again hard, so it drops even more because you're burning more fuel. Then you have a little cruise, so it starts to come back up again. Then you stop again, so your mpg drops. So what's happening here is you accelerate, then brake, accelerate, brake, and what you're doing is you're burning a lot of fuel, not very much as you cruise. Then it's 0, burn a lot, not very much, 0. See what I mean? It's sort of a better way of doing it would be this one. So now we gently accelerate and arrive at the lights when they're green, thus maintaining a higher average speed. So rather than burning a load of fuel, we just accelerate, go up to 20, then to 30 miles an hour, but more gradual rather than straight up to 30 like we did before. So now my average has actually come up a bit. My MPG is better than it was. It was much lower on the previous slide. I've got a comparison in the middle. Then I maintain this, so my average is going up. So I'm just cruising, so my MPG goes up. Now here I take my foot off the accelerator and I do a long gradual slow down. Because my foot's not on the accelerator, my fuel economy goes through the roof, because basically you're not burning any fuel. So my MPG goes up. I've put in 100 MPG, but it actually says infinite on the display because we're not burning any, are we? So subsequently my average MPG at that point when I'm approaching the traffic lights is actually going up, whereas previously it was diving, and so on. Now this time I've gone down to 20, arrive at the lights at the right time and accelerate. So I've only got to accelerate 10 mile an hour, whereas before I was stationary, I had to accelerate 30. So my acceleration phase is much less, it's more gradual, and so what's happening is my average MPG goes up, then it dips a little bit for the re-accelerate, then it just keeps going up, and it goes up again when I take my foot off the accelerator. Much more efficient.